then there is a very important concept which we have said as on delete or on update clause, right? So because this on delete and on update clause will have a significant effect when we will be uh, dealing with the data values. And naturally, among the database in the database among the database tables, in some cases there will be parent child relationship exist. So until unless you define this on delete or on cascade, you will not able to force some changes uh, between this parent and child clause. And particularly in the child table, you cannot be able to perform anything if you have not defined this on delete or on cascade, on delete and on update clause, right? That's why we have class, we have discussed it in the previous lecture, that whenever we are creating a database table and you are observing that one of the table will be acting as a child, then you have to place this on delete and on update clause to have a systematic manipulation on the database table, right? So today we are naturally going to extend the discussion. So in the previous lecture, we have talked about the create, all the possible combination, all the possible clauses in a create clause, create command, you can say, right? And the purpose was to simply create the database object, right? So that is about creating the database object. That's the first objective which a particular DDL expression will be serving. Now we are going to discuss the next part, which is about managing the existing object, right? So when I say database objects management, right, we are not talking about the database value, right? We are talking about the database objects definition, only definition, right? To create the database object, let me put it in a straight way, definition, right? Similarly, so similarly here also it is talking about to manage the existing database objects definition. That is very important, right? You should not be confused with the term that it is talking about database or database uh, entire database value. It is only specifically talking about the database objects definition, right? So now we are going to discuss three broad basic clauses which are there for basically managing or maybe manipulating or maybe altering the database definition. So suppose you have already created a database object by using create. Now there are some situations where you need to update the database tables definition, right? We have given you assignment to create the database, company database, right? So in the company database, sometimes it is possible that two database tables are interleaved with each other. Like department table is dependent on employee and employee is dependent on department table. Because of this you can say the deadlock kind of relationship between department and employee due to foreign key attribute, will not able to decide which particular table should be created first, right? So in that case, in these kind of situations, there are many situations where you need to use these alteration, these manipulation kind of clauses during the database creation itself, right? So naturally in the data record insertion, record updation, that is the second part. But right now, because we are talking about database definition language, and in this, there are some situations where you need to use these data manipulation, data alteration kind of expressions, right? So in the very first command or clause which help you to perform these changes on the database object is alter, right? So alter is there to help you on the situations where you want to perform some changes, whenever you want to modify a database, existing database object, right? Naturally at the level of database. I'm not talking about the alteration on the level of database. We are talking about the database table level modifications. So you can modify the existing database object naturally at the database table level, naturally its definition, right? And if you see broadly in the database table, because we are saying alter will help you to modify or to perform changes on the database table. On a database table, you could have possibly two things which you can change. First is naturally you can add or remove the database attribute, right? And second will be it is the removing or addition of the database attributes and their constraints. So you can have possibly two things which you can modify: attribute and constraint. So typically on these two aspects, attribute and constraint, you can perform two operations. Either you can add attribute, add constraint, or you can remove attribute or remove constraint. That is the four possible use cases, right? Adding and removing attribute and constraint. So there are four types, four situations where you can use alter. That is obviously clear. Now there is this there is this fifth use case basically, which is called or required in case of you want to perform some, you want to rename the database attribute, you want to update the name of the attribute, right? Because renaming an attribute does not serve any purpose. That is one thing. Renaming a database table will a different use case. We are talking about the modification at the level of database table, right? So if we are talking about that, we are going to modify, we are going to perform some changes on the database table level. It means you cannot change the name of the database table itself. So here we are talking about the changes on the database table. So it will be related to attribute, it will be related to the constraint, right? In some cases, it is related to renaming the database attribute also. So let's take one by one, and we'll try to understand briefly because it does not have many variation. This alter expression does not have many variation. It will be purely depend on the term or the operation which you mention in between, right? So like here you can see, typically we have simply typed a simple expression. In this expression, you can see it is said alter table student, which is the name of the table on which we are going to perform some alteration, right? So after typing this alter table student, you have to specify on this table student we are going to perform some alteration, and the operation which we want to perform is addition, add. So you are going to add something on the database table student. You are intended to perform some addition. Now what we are going to do, we are adding, simply add the name of attribute, then its data type or its size. So this simple expression says you are trying to add attribute address with varchar data type of size 20 on the database table student. That's a simple clause. Similarly, you can type it in a extended way. It is like alter table student, add address, varchar, and its constraint. So there could be two variation you can have. So suppose you want to add attribute, you can prefer either of these expression. In the first expression, we have not mentioned any constraint. On the second statement, we have added attribute along with its constraint, right? So these are the two ways of adding or writing expression for altering or adding the database attribute on the database table, right? After this, if you see, there is a need of, in some cases, there is a need of attribute removing or removing a database from a database table, removing a database table's attribute from a database table. Now, it is quite similar. Alter table student. This specify that you are going to perform some alteration on the student table, and alteration is what it is asking about removing the attribute which is named as DOB. So you need to simply mention remove the name of the attribute. So by this you can simply remove a database tables attribute, right? So this could be very simplistic. You might have experimented with these things because now we have up to around 2 months for the slave started. So maybe in some steps we have done it. Naturally, one thing is very important here. So suppose we are removing, during this removing part, whenever you're trying to remove a certain attribute, one thing is very relevant here, that whenever we have, suppose we have created a database table where one of the table is acting as a parent and other is acting as a child, and you are trying to remove a database attribute from the child table, right? Or maybe parent table, let's take. So if you're trying to remove a database tables attribute from a parent table, and you have not defined these constraints, which we are saying that on delete and on update, on that case, its system will not allow. If that attribute which you are trying to remove is serving as a foreign key, so it will not allow you, right? So that's why it is recommended to always define these on delete and on update cascade. So you will be free from these constraints once we have defined these constraints on the child table. system will automatically take care about it, right? Because along with the on delete and on update, you will be defining these parameters, whether it is set null, set default, or set a cascade, right? So that's why it is kind of best of art or best of practices, that whenever you create a child table, you should always impose these constraints, right? And it will have only effect. So if you have altered table student and remove the D number, or maybe SSN number, or maybe employee number, so on that case, if you are not defined these clauses, system will not, deviance will not allow you to perform this task, right? So that's a kind of note for you. Now going ahead, so these two cases we have discussed, right? Adding and removing the database attribute, database tables attribute particularly. Now the third possible case could be relating to adding the constraint. Now what we are trying to do, we are trying to add a constraint on the existing database table. Naturally, for this, the database attributes should be existing. That's the basic requirement. That whenever you're trying to impose a constraint, the database attribute, database tables attribute should be existing. It should be already defined, right? So typical syntax will be, alter table student. That's simplistic, as previously we have used. Now you have add as a term, as an operational term. Now what we're going to do, we are simply trying to add a constraint. So you need to address, we need to add this term called constraint. So this is system defined term, uh, along with the alter and table. Add is also system defined term. Now you have to mention, or you have to assign a typical name. Now what we are going to do, we are imposing a constraint on address attribute. Constraint name is not null. So this address attribute is existing. Now what we are trying to do, we are trying to simply add this constraint. And whenever we basically execute these kind of experimentations, systems say you should always mention a name. So this not null constraint on address attribute is named as const1, right? So this const1 is user defined. You can mention your name also. That's up to you, right? You can give like address const1, address not null. So this const1 is a user defined value. You can opt for anything which you want for your reference purpose in the future. So this is the typical statement for adding a constraint on existing database tables attribute. Alter table student, add constraint, the name of constraint which you want to give, then attribute name on which you are trying to impose a constraint, then constraint name, right? So with this, you can assign a constraint on attribute. So similarly, whenever you use alter expression for adding a constraint, you should have a practice to give a name. In some databases, in some database DBML softwares, they will not ask for this const1 kind of thing. They will simply say add constraint, attribute name, and not null, something like that. But in some DBMS, it is mandatory to have this name of constraint, right? Now after this, naturally, once you added the constraints on the database tables attribute, the second possible case is to remove the existing constraint. So by remove the existing constraint from a database tables attribute. So naturally, for this, you have already defined these constraints, and now you want to remove it for some purpose, for some reasons. Now what could be the possible syntax? It could be altered table student. Now remove is the term which you should impose, because you are trying to remove, like in the previous case what we have done, to remove database attribute, we have simply mentioned remove, then attributes name. For removing a constraint, what we are going to do, we are going to mention constraint as a system term, and with that you are going to use this term which is user defined term, right? So const1, so by simply referring this const1 name, system will automatically picks up a particular constraint which is defined on the attribute and remove it. It will drop the constraint which we have already imposed on it, right? So this is one of the use of defining or giving the name for each constraint. That is the simplistic use of it. By simply calling the user defined name, you can remove that constraint, right? So these are the four possible cases of alternate. Let's see the last one, which could be if you want to rename the database attribute, right? So renaming a database could be like, it will simply overlap or override the previous name. So to rename the database attribute, you can possibly use alter table student rename. Right? Renaming is operation. Now you should give this operational name, rename, then attribute. So you need to list down the attribute name. Attribute name. It could be the old name also. So attribute name, previous name, and new name, something like that. Right? So let me rectify. So it will be like this, something like that. So if you mention it, so it will take this as an old name. Second, this will be the new name, right? So in some databases, it says, okay, rename is not working, so you should be using modify. So alter table student modify, then attribute name, old name and new name. Alter table student, in some it is change which is supported by, and then with that you can mention this old attribute name and new attribute name, right? So these are the three possible alternatives you have on the different DBM systems to rename a database attribute, right? So with this, these are the 5 possible cases or use cases of alter clause, uh, to basically modify the existing database object, which is database table right now, right? And naturally, there are 2 possible cases we have, which is typed here. You should be thinking about it, like we have performed the changes on attribute label within the database table. Now, if you want to modify or change the database table name, what could be the possible tool or possible expression for it? Suppose you want to change the name of database itself. You want to make it database 3 instead of DB3, right? So you need to think about, because by using alter, you can modify the database attributes name. You can perform the changes on the attributes, right? So we will be naturally coming up to these points. Now, next DDL expression is truncate, right? So truncate we will discuss with the discussion during DML. Just for the time being, you can take out that truncate is basically dealing with the data values and the definition of the database objects. So in the future, when we will be uploading the data records into the database table, there will be some situations which says you need to remove all the records from a database table. I'm saying database table, not I'm saying database, right? So there will be some scenario like you need to remove the all student records, you need to remove the all project details, you need to remove all the employee records, right? For all those situations, you will be using truncate. So truncate will erase all the data from a database table, right? Without removing the database table's definition. That is the simple line for which truncate is being used. Naturally, whenever you are going to use the truncate, and naturally suppose that table is being used as a parent table, then you should be what? You should be defined, you should have defined all these on delete, on update, cascade. Then only system will allow you to remove all the database records, right? So TML, this truncate is having very specific use. It will be used for the instance where you want to remove all the database records from a database table without removing the database table's structure, right? And suppose you want to remove both database table as well as its definition, then you can use drop. That's for the drop is there. So it will simply remove the database definition. It means if you are removing the definition, it means the data will automatically removed. So suppose if you have created a database table and for some reason it has been asked that you need to remove the database table. So it will automatically carries out or erase the database values which has been stored into the specific database table, right? So for that you can simply say drop table and then student. That I think this is also you have been used many times. So in some data DBMS softwares it is drop table student which is supported. In some it is simply says drop table because you are already within a database. So if you mention drop table, drop and then table name, it will simply take out that you are talking about dropping the database table, right? Because to remove a database attribute, you have something else. So if you mention drop student without mentioning drop table student, it will also take in some DMS. For some, it is drop student simply, right? So we have talked about dropping or removing the database attribute, removing the database table. Now, next possible could be how to remove the database itself. So for that, you need to explore what could be the possible alternative to remove. Suppose in some cases, from your data, from your hardware system, a storage device, you want to remove the entire database. So what could be the possible way for doing it, right? That you should be exploring about. Now, the last clause in the DDL is rename, right? So the renaming is naturally because we are talking about now at the DDL level. So if you talk about renaming, it is naturally to rename the database table, right? So by using rename, you can perform the changes or you can rename, update the name of database table. So because we are already at the level of database, it means you cannot rename the database by using this rename expression. For that, you need to look for other options. Now, by simply mentioning rename, then the table old name, the previous name, and with the new name. So it will simply rename or update the name of database table within a database, right? So with this, we have covered most of the concepts related to the DDL, and actually you should be carefully using these clauses while creating or while updating the database definitions, right? And these DDL clauses can be used on the database at any point of time of the database lifetime. Like if you have created the database tables, and suppose after updating the records, after uploading the database records onto the database table, you can also perform these changes, but you need to preserve the constraint first, right? Constraints means these constraint, 5 constraints, and their relationship with the other database table. So the dependency needs to be checked. But like you can always add a database attribute, you can always add a constraint. But whenever there are some value or stored in the database table, you need to think about the existing value before imposing a constraint, right? So suppose there is an attribute where the values are repeating, and now you want to impose a unique constraint onto it, or maybe primary key onto it. So you need to think about it. You need to update the values, because DBMS will not automatically adjust the data values. It is the user who has to perform these changes, and then you can impose a constraint, right? So based on the existing values and existing relationship among the database tables in a database, you can always perform, or you can perform any changes at any point of the time of the database, right? That's what. So you need to ensure about the constraint. You need to ensure about the database values which are available, which are existing. So with this, I can say the DDL part is done. Now you should be able to uh, create and alter the database table. That should be the minimum thing you should be aware of. And I hope you are partially going through all these things, all these concepts, and experimenting with all these concepts in the lab also, uh, because that is the minimum thing which you should have. You should have idea about it, right? Now after this, naturally we have talked about DDL, which is there to create a database and its database tables and attributes. The next possible set of expression is naturally related to the DML, which talks about primarily the values. Now we have moved ahead towards the value creation on the database, towards the values creation on the database table. That's the purpose of DML. And here you can see it is talking about manipulation. So data is always there because it is something about the data definition, data values, and data access. So that's why prefix data is there. Now manipulation says you are trying to perform the manipulations. So manipulation starts from creating, updating, and removing. These are three possible stages of any kind of manipulation, whether it is manipulating an individual, its opinion, whether it is updating or manipulating the value, or maybe any culture or any conventions, right? Now, when we say manipulation of data, it means it is about creating inserting or uploading the values onto the database, and for some needs, performing changes or updation on the database records, and because of some needs, in some cases, in some portions, it is the removal of some records, right? I'm saying some records, right? Because DML never talks about removing all the database records. It never talks about inserting all the database records. You cannot, yes, naturally, in some cases, you can upload the bulk records, but it is not about that. In one single expression, you can upload values on all or many different database tables, right? So you can upload the data records in one database table at a time, right? That's the minimum bottom line. Similarly, you cannot update all the database records, all the database attributes in one go. You cannot remove all the records from a database table in one go, right? So data manipulation says it will be performed in a controlled way, or maybe a scaled way, right? So let's understand. So naturally, the bottom line is what? You must carefully maintain the primary key and foreign key violation. So while creating the database record, whenever you tries to insert a invalid value, invalid means it is not falling into the definition of the database object, definition of a database tables object. Suppose a database table attributes is defined as a primary key, and now you're trying to insert again and again same value. So system will not allow you. System will not accept this constraint, this simple expression, right? But you should, as a user, you should always carefully plan the values, right? So these primary key, foreign key, and along with these other constraints also will be imposed, will be ensured by the DML system. Okay, so within this DML, there are not a very specific set of expressions. We have three types of expressions. First is it naturally to create the values, to upload the values on the database table, and it is by insert, right? So insert is expression. So it is simply to create the records about values. So I'm using these two terms, records and values, interchangeably. Records are basically what? In a database tuple or in a row is having multiple values, multiple records, right? So suppose if you see the student table, one row or one tuple will have name value, his first name, last name value, DOB value, department name, his email ID, and everything. So each and every cell is referred as a record. And if I say it is records, it means it is talking about more than one values, from more than one columns, attributes, right? Values are also equivalent. And whenever we say tuple, it means it is talking about set of all the values, set of all the records in a row, right? So insert is primarily used to either insert a single record, multiple records, right? That's what the purpose of insert. And in this whole process of creating the records, uploading the records, you should maintain the. Maybe DBM system will preserve all these things, but as a user also you should carefully plan the insert expression, right? So let's take a simple instance or simple example. So suppose there is this table defined given with a student as a name, as a character, DOB as a date, address as a varchar, email as a varchar2, D number is integer. So suppose this simple structure is given to you where you need to or you want to insert the values. So expression could be insert into student. So this signifies that okay, we are trying to insert values into the database table student. Now after this you need to mention values as, because you have mentioned that uh, in this particular database table student we are inserting the values. And what is the value list? It will be like this set of values, right? So you can see here we have mentioned these, I think 1 2 3 4 5, 1 2 3 4 5. So we have mentioned 5 values within the bracket, which says you are trying to insert a record set. We are trying to insert a tuple in the database table student, right? So here you can see we have not bothered about the sequence of attributes in the student table, we have simply mentioned the list of values. And this is your responsibility, that you should list, you should mention this value carefully, right? Here it is easy because we are having only 5 attributes in student table. And suppose a database table have around 15 or 20 attributes, what could be the possible, I mean, that will become difficult because you should be remembering, you should be have this tendency to recall the attribute sequence, right? In some cases it is difficult, uh, uh, that you're not able to mention it. So on those situations you can simply mention the attributes name here, right? So if you are not able to recollect these attribute sequence, on those situations you simply mention insert into a student, and here you can mention like dob or name, something like that, and then email ID, and then uh, D number, then what we have missed, address we have missed, address, right? So 1, 2, 3, 4, 5. So after this, you can simply mention values. So it's already there. So once you mention these attribute sequence, now you need to rearrange them. So you need to take out like the first value should be dob as a, right, and second will be your name, and third will be your email address. So let me take out email address, this, third will be email address, and then this d number, which is 6, and then it's already there, d number is, yes, yeah. So if you are not able to recall the sequence of attributes in a database table, you can explicitly mention here. And after that, you need to impose the values as you need, right? So basically, this provides some sort of facility, I mean, facility to you, and particularly in the case of a database table, which is having many attributes. Okay, going ahead. So the next possible expression could be like insert into student values as, and here what we have done, we have tried like John, then this, and it will show some error, right? And it is because of this value, right? If you can see carefully here, this value which we are trying to insert, it is having more than 5 values, and in the student table we are having only 5 attributes. So now you can see John is first value, then separator, then dob, separator, then we have what we done, we have done 102 comma dl ind comma. So by simply inserting this comma, and we are assuming this as a value, address value. Previously it was 102 dl ind, and we have not placed any separator. So it will be assuming this 102 dl ind as a single value. But when you introduce the separator, it automatically becomes, so total values will be 6, which is not equal to the number of attributes in the database table. So by this you can simply pose a simple code, single code, and this assumes that this as a single value, right? It's important because this could be the typical syntax for the address value, like house number 102, it's Delhi, it's ind India, something like that, right? So it is important because in some cases where we are trying to insert some values, these kind of values will be appearing, and these kind of attributes are called as a, let me write here, composite attribute, right? And it is like address. So we, where we have house number, comma city, comma uh, state, comma country. Yeah, it's right now. So whenever we have these kind of values, attributes, which could have many fields within it, right? In one single address value, we could have 102 DL, then separated by IND, something like that. So let me type here DL, DL, and DL, something like that. So within one value, there will be many fields available. So I am referring as a field, not record, right? So this is a one record, and within one record, so we have these 5 records in one, for one single student, and in record is in particular record student address, we are having 4 different fields. So first field say house number, it is about city, it is about state, it is about country, and these kind of attributes are referred as composite, right? Similarly, your name could, I mean, student name could also be a composite because it consists of uh, you know it consists of first name, last name, and middle name, right? So in some situation we have these kind of attributes. So basically this is one of the type of attributes, like we have discussed what a simple attribute, a multi-valued attribute, derived attribute, and sometimes it is composite attribute also. Okay, so now going ahead, what we have now, insert into student values as John. This it has been rectified now. Okay, this, let me remove it because we have already rectified it. Now next value is about again it is talking about lesser number of values. Here what we have, what happened? It was taking 6 values which was not matching. So if you tries to lessen number of values like John, this value, so here we are trying to insert only 4 values, which is less than the actual number of attributes in the database table, and this also impose a error. So again, so whenever we are writing insert expression, these could be the initial mistakes which you will be having. Once you have been carefully observe the schema, you will not be able to committing the same mistakes. Now there is this expression called insert into student, then values as. Now if you see John, its date of birth, and we have not mentioned anything on the address field, right? So on the address attribute, we have not inserted any value. You can see it is a null value, and this typically signifies the null values notions. So null value, which we have discussed, that it is a non-physical and non-agar based value. It is neither a physical or nor agar based value. That's what null means, right? And it says possibly three reasons for it. That address is not available right now. It will be available in the very next day. That could be one possibility. Second, it is not applicable, right? In some cases, suppose we are having few students from the Islamic country, other countries, it is not required for them. Country says or policy says it is not required, or it is not applicable for these students. In the same database tables, for some students the address is not applicable, right? And it is coming from a policy decision. And third possible case is address does not exist. For some students, for few students, it is possible that address does not exist. They don't have any specific address, right? Something like that. So whenever we have this null instance on a database, there could be 3 possible reasons for it, right? And this is typically a very important concept of a database. And we will be discussing more about the null value and its implication when we will discuss the retrieval queries after this DML thing. So whenever you are trying to insert null value, system automatically preserve a space for possible value or possible logical decisions. Now after this, suppose we tries to introduce null value. So like this, by using simple expression, insert into students values as John, and with this value, this as a roll number. Now we are dealing with a different database schema, and this date of birth. Now for these 3 remaining places, we have kept it null, right? And it will create a simple database record tuple in the database table student with these three fields as a null, which is address, email, and D number. Now if you again insert the same value, like the same expression has been executed, the same expression which we have just introduced, it will show a error like the same set of attributes, same set of values and attributes are being introduced. So it will show a primary key violation because the values are already existing in the database table student. Similarly, and this is something very obvious, right? And if you modify this this value, which is roll number, because for the student schema which we are observing, roll number is the primary key. So if you update this roll number value, system will takes each and every value. Like John is introduced as it is in the second row also with the same values. So system will verify only the roll number constraint, because in this schema we have introduced only constraint primary key and the roll number. So it will check about, it will verify this constraint only, right? Now, going ahead, so if you want to create two schema, now it will we will discuss the clause of foreign key. So suppose we have created a database schema with the department and attribute d number as the primary key, and a student table with the roll number on the roll number as the primary key and d number as a foreign key. You see, you should carefully see here. Now, after this, if you try, so suppose we have introduced two rows this in the database department table with the 123 as a d number and cu as a department name. Similarly, another row like 234 as a department number and it is a department name. Now if you try to insert into the student table, insert into student values as ram 3457 as a roll number, this value is this, and 456. So suppose this particular row you are trying to introduce, so system will show error and it is said as a foreign key violation, and it is because this value 456 on the d number, which is a foreign key attribute referencing to the database table department and its attribute d number, this value we have not introduced. This 456 as a d number is not being created in the database departments table on the d number attributes. So when you tries to insert a tuple in the on the child table as a student child, it will show a foreign key violation, right? Typically, and once and after in the very next instance, if you observe that this 456 is being created in the department table, the same expression will be smoothly executed, right? So this is about creating. So you could be possibly facing primary key, foreign key violations in the creation phase also, right? Now after this, if you observe that all the database values are created in the database table, there are many cases where you need to perform changes on the values, right? Maybe because of requirement, and in some cases it is because of changes on the policies, something like that, right? So for that, there is a constraint called update. Update constraint or update clause is there to modify the existing values from the database or on the database, right? And it is about modifying the single value or maybe set of values. So you can modify the multiple values, right? Or you can perform the changes on the entire value set in the particular attribute, right? So while updating also, you need to preserve the constraints. Naturally, database system will take care about these things. System will not allow you to modify perform the modification which violates the constraint that is primarily. Now, what could be the possible syntax? So suppose you want to update the student's name. There's a typical example of it. And now you want to do what? You need to simply type update student. It means you are trying to perform update on the student database table. And what is the update you are trying to perform? You are simply making it possible on the attribute on the attribute name. So on the name attribute, you are trying to assign a value SHYAM for a student where roll number is 34 something roll number. So you have provided a condition, and condition says for a student whose roll number is 34578, you need to update or you need to set the name value SHYAM. So this will simply override the value, right? And if in some cases if value is not available, so suppose you assume that in the previous case for this student the name was not provided, it was null. So you can perform a simple update operation to update or to insert or to create this role name for this student roll number with this, right? Now the attribute will be looks like this. This could be the possible change after change effect. Similarly, if you want to perform the change on the entire set of values on a particular attribute, so simply if you want to increase the name of simply increase the mid-semester 1 marks for each and every student by 0 to scores, So you can simply type update student and set midterm 1 marks equals to midterm 1 marks plus 2. So because we have not mentioned any condition, any logical condition here, this change will be performed for the for each and every student listed under a database table student, right? So all the values in the attribute called midterm 1 will be increased by 2, right? That's the simple implication of update. So update is something, it is being used by various transactions. Whenever you ensure we execute a simple expression by using some transaction, update is something which is primarily being used. Right. And last possible set is clause is delete, and it is primarily used to remove the database records from the database table. So after performing insertion, then updating some values, the last is the scenario where you need to remove a particular database value, remove a set of values from a database table, both cases. So when we say records, it means it could be removing the single value, set of value in the attribute, multiple values on the database tables, right? So naturally in this process also you need to maintain the constraints. So typical syntax could be, I mean, one expression you can choose, you can check is delete from a student table. So this expression you need to check whether it is working or not, right? Because this seems that it will be removing each and every value from the database table student. So then you have that you have to verify whether it is working or not, right? So after this, if you specify expression like delete from student, now what we are going to delete, what we are trying to delete, it is where d number is 1 to 3. So we have mentioned that you need to delete each and everything where d number, which is attribute, wherever it is 1 2 3. So maybe in the database student table there are 4 5 6 students are there, are existing, where value is 1 2 3, d number is 1 2 3. So it will remove multiple 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 rows where d number appears 1 2 3. That's the simple implication, right? Similarly, if you want to modify or if you want to remove the student's record, all the students who have date of year, date of birth year is 1990. So the typical syntax could be delete from student where dob like. So this like thing is a new term, new comparison operator, and it is primarily used to compare a partially available input. So you can see here dob as an attribute is having a month, date and year, but what we have mentioned within the single quote percentage 1990. So we know that in this dob column, dob data type, last 4 digits are for year value and first 4 digits are for month and date. So for the first 4 positions we have used percentage, which is basically a flexible kind of string. So whenever you want to compare with a partially available or flexible kind of input value, you can always use like, right? So that's what we have done. dob like within the quote percentage 1990. So it will remove all the students rows or tuples where the birth date of birth here is 1990, right? So this we will discuss that what could be the other persons. So we will discuss like and this percentage thing when we will discuss substring matching in the upcoming classes. Now, right? So these are the possible cases of delete. I mean, typically you can delete one row, one single record, something like that by using simple expression. Now let's compare what is the effect of truncate and how it is related to the DML expression. Now, if you see, we have mentioned that within the DBL set, which is the previous set, Truncate is used to remove all the records, all the values, all the record sets from a database table, right? And delete is also achieving that purpose in a partial way. Delete cannot remove or erase each and every record from a database table, right? So typically, if you see, truncate is used to remove the data records from a database table. Truncate is used to remove all the database records, all the data values from a database table without affecting its definition, without removing its definition. Drop is there to remove definition and data both, and delete is to remove only few set of records which are basically matching with the logical condition, right? So that's it. With this, I can say we have uh, completed the discussion on DML, and now from the next lab or next lecture, we will be discussing about the retrieval queries, naturally on the Monday, on Monday onwards. And I hope you have experimented with these basic expressions, because we have somehow able to create the database table and able to database insertion of, or manipulation, right? So once we have done with DDL and DML, now we will be discussing about the retrieval part, and that will consume around 2 to 3 lectures about it, because it talks about many functions, many logics, and many arrangements, query arrangements for that, right? Thank you for this lecture. Thank you. Now, if you have anything to ask, just let me know.